Hello, my name is Robert Behrens. This is the first Fluent project for Dr. Osbay's Fundamentals of Aero class, fall 2023. So this is the rotating cylinder. This is part B. This is the rotating cylinder on with the flow going over it. So we're going to do Fluent like always. We will open design model or geometry. Give that a second. All right, we're loaded up. Get our axis, do an XY plane. So we're gonna make a cylinder with a big box around it. What I'm gonna do, I'm gonna make these two reference lines, and I'm gonna give them a dimension. I'm gonna make these 30 meters long. They really don't have to be that long at all, but that's what I did in mine, and it worked fine. So, but you could do them however you want. And then we're gonna make a rectangle. Let's make it however, and we'll go to constraints, midpoint, select the line, select this point, just like that, get a midpoint there, select this point, like that. Then you have your 30 by 30 box. Get out of that, and then select these lines, delete these lines. Then we'll draw a circle right at the origin, dimension it, diameter is going to be 1 meter. So you got a really small circle in a really big area, which you don't need, of course, but for some reason that's what I did. So we're going to do concept, surfaces from sketches. We're going to select our sketch 1 right here. We'll apply, and we'll generate. And we should have our little hole right here, and a really big box. All right, so we made that. We'll go over here to mesh. All right, we're loading our mesh right now. Here we go. So I'm just gonna generate it really quick. Let me see, that's what we got. That's not what we want though. So what we're gonna do is we'll insert a method. So right click, insert method, select our geometry, and then I like to do all triangles. Generate that, see what it looks like. Still way better, not really what we want. So now we'll insert inflation. And what we'll do is we're going to select, this is our geometry. Our boundary is going to be our edge right here. And let me just see what I did on mine. So I did 5 max layers, and everything else I left the same. So we can generate that. See, we got our layers right there from our inflation. Now we will insert edge. Sorry, edge sizing. Had to look at my assignment really quick. All right, sorry, it's been a while since I've done the Ansys Fluent projects in Fluids. This is the first time I've used Fluent in a while. So it's just, you just insert sizing, and then you're gonna select your edge, and it becomes edge sizing. So I did that, and then else should be the same. Capture curvature, yes. We'll generate that really quick. This might take a second to do. All right, and then we'll look at it. So, got really fine mesh right there. The rest of it, not really as fine. So that's where we're going to go to our general mesh element size. I used 0.15 meters. And we'll generate that. And this is where we'll get our like really nice fine mesh. Look at our progress. All right, so that took a little bit longer than I wanted it to. This honestly looks finer than what I did in my project for some reason. I used the same dimensions and everything, so it is what it is. It's fine. Now what we gotta do is we're gonna name our edges. So we'll select it, click N, inlet, outlet. We will select both of these by holding Control, and we'll do walls, and then select our cylinder. Cylinder wall. That's what we'll do. All right, so that should be perfect for what we want. Your meshing really doesn't have to be that fine, but it's fine. All right, we're gonna update our mesh. Now we'll go to setup. I like to do double precision for solver processes. Let this load in. All right, we're good. So for this part of the project, we're gonna wanna go to viscous, and we're gonna do laminar flow for this. For the other part of the project, without the rotation of the cylinder, you would do inviscid. But for this, we're doing viscous, or sorry, laminar. All right, so materials, our fluid is air. Double check, everything looks good here. Good constants. Boundary conditions. So our inlet velocity on this project is going to be 10 meters per second. We'll apply that, close that. Now what we want to do is our walls are walls, outlet, outlet, we got pressure outlet. Just make sure everything's good here. Yep, everything looks good. Inlet is our velocity inlet. Now cylinder wall, what we want to do, because we're rotating it this time. And I'm going to do the third scenario. Let me actually pull it up for you right now. Okay, so I'm going to be doing this one. And that's what we're going to model today. So cylinder wall, we're going to go to moving wall. And what do we want on here? Our speed. Okay, let me take a look really quick. Okay, just want to make sure I got this right. So it's going to be rotational. We're rotating it. Everything else is going to stay the same. Our speed is in radians per second, which means, and we want a clockwise rotation, so we're going to be negative. And I'm doing negative 120. That's what seemed to work for me. Dr. Osbey said to just do what makes it look like in here. So for whatever case, you're not really calculating how many radians per second you're going to use. You're just going to do it. If it looks like that picture, you're good. And it's not going to be perfect because it's laminar flow. So let's go to reference values. We'll compute from inlet. Everything looks good here. All right, initialization. Now we can change the number of iterations. So we'll do like 50 iterations for initialization. We'll initialize that. All right. Now we can go down and run calculation. And I'm going to do, I did 300 iterations. That worked for me. So calculate that really quick. Shouldn't take too terribly long. Okay, that took like a lot longer than I thought it would. It was probably the meshing. The mesh was probably way finer than what I had before. I don't know why, but should be all right. I'm really hoping it's all right. If it's not, I'll be kind of mad because then I have to re-record the video. So I'm gonna see if our contours and our streamlines are correct from what they should look like. All right, so here's our little cylinder. What we want to do is we want to add some streamlines. Streamline 1, that's fine. So we'll do symmetry. Symmetry 1 and 2, like, I've messed with it. Doesn't really make a huge difference. I kind of forgot how many streamlines I used. I think I used like 200, I want to say. Let me double check. All right, so 2,000. I used 2,000 streamlines. Okay. Because it's such a big area that if you don't use a lot, you get like weirdly placed streamlines. Not weirdly, they're equally spaced, but they're all so far apart, it doesn't tell you anything. But use 2,000 and you're good. And yeah, so we want velocity and direction forward. Those you don't really have to change. Yeah, this is good. This is correct. And you can even probably put some more. These are kind of spaced out, but I would say for the purpose of this project, you're fine. And this looks pretty much like how it's supposed to. And then you can mess with your variables. Oops. Mess with your variables and your rotational velocity. And you can change your legend right here. But the other two things we need are our contours for velocity. So contours, we're going to do location is going to be symmetry 2. Velocity, global. I think I did 100 contours. Again, it's a big area. And then we'll get rid of our streamlines because those kind of like make it not look as good. That's pretty much what you should have too. It should look similar to the streamlines with the colors. Like it's, you turn this off and it's like the same thing. But then we want our pressure contours. Sorry, I'm gonna do symmetry 2, 100, pressure, correct. Yup, that's also correct. So what else do we need for the project? We need our lift and drag coefficients, and those you calculate from the equations for those. But we need to go to reports because we need our forces. So for our drag coefficient, we're going to do the force in X on the cylinder wall. And it's going to be this number right here. And then for our lift coefficient, we're just going to put Y1. x 0, print, and that's our number right there. Seems like a lot, and I thought I was way over, but when you look it up online, I looked up like how high of a lift coefficient can you have. Rotating cylinder was the first thing that popped up, so it makes sense. All right, so these are the equations you're going to use for your lift and drag coefficients. That's literally just like coefficient of lift. So you have your forces, directional vector 0, 1, 0, x, y, z. That's your forces in your y direction, which is going to be your lift, vertical. You're just going to, this is your force right there.